So now let us solve a few questions on continuity of a function. The first question is, prove that the function fx equals to 5x minus 3 is continuous at x equals to 0, at x equals to minus 3 and at x equals to 5. So let us first find the continuity of the function at x equals to 0. So function is fx equals to 5x minus 3. So at x equals to 0, fx is continuous if limit x tends to 0 fx equals to f of 0, that you have already studied about in this section. So left hand side is limit x tends to 0 fx equals to right hand side is f of 0. If this equals to this, then we say the function is continuous. Now let us see to the left hand side, limit x tends to 0 f of x, that is limit x tends to 0 5x minus 3. So putting x equals to 0 here, we get 5 into 0 minus 3, that equals to minus of 3, that is minus 3. Now on the right hand side we have f0. So putting 0 in this function 5x minus 3, 5 into 0 minus 3 we get minus 3. So here we see that the value on the left hand side equals to the value on the right hand side. That means limit x tends to 0 fx equals to f of 0, which means that the function is continuous at the point x equals to 0. In the similar way, we can prove that the function is continuous at x equals to minus 3 and at x equals to 5. Okay, I hope it is clear. Now we move on to the next question. The next question is, examine the continuity of the function fx is equals to 2x square minus 1 at x equals to 3. So the function is fx equals to 2x square minus 1, and we have to check for the continuity at the point x equals to 3. So in the similar fashion, just as we did in question number 1, we will proceed at x equals to 3. Limit x tends to 3 fx is equals to f of 3. So that is what we have to prove. So let us find the left hand limit. Left hand side is equals to, we have limit x tends to 3 fx equals to limit of x tends to 3. The function is 2x square minus 1. So this equals to, put x equals to 3, putting x equals to 3 here in this function. So 2 into 3 square minus 1, that is 18 minus 1, and that is equals to 17. So the left hand side we are getting the value as 17. Now let us see what is f of 3. That is the right hand side. Equals to f of 3. That is 2 into 3 square minus 1, that is 2 into 3 square 18 minus 1, and that is equals to 17. So we see here also the left hand side is equals to 17 and the right hand side is equals to also 17. So we have limit x tends to 3 fx equals to f of 3. Hence the function is continuous at the point x equals to 3. Now the next question. Question number 3. Prove that the function fx equals to x to the power n is continuous at x equals to n, where n is a positive integer. So in the same fashion we will move. We have to check for the continuity at the point x equals to n. So at x equals to n, limit x tends to n, fx should be equals to f of n. So for the function fx to be continuous, limit x tends to n fx should be equals to f of n. So this is the condition. Now let us see the left hand side. Left hand side is limit x tends to n, f of x is equals to limit x tends to n, x to the power n. So putting x equals to n, we have n to the power n. Right hand side, we have f of n. We need to find f of n. So this is equals to n to the power n. So we have the left hand side equals to the right hand side, and that is equals to n power n. So this condition is fulfilled, that limit x tends to n fx equals to f of n. Hence the function is continuous at this point x equals to n, where n is a positive integer. So now we will move to the next question. Now let us move to the question number 4. Question number 4 is, if fx equals to x square minus 1 by x minus 1 when x is not equals to 1, and is 2 when x equals to 1. Find whether fx is continuous at x equals to 1. So similarly we will proceed. Here you see, we have to check the continuity of this function at x equals to 1. So when x is 1, the value of the function is 2. So to check, we have f of fx is continuous if we know limit x tends to 1, f of x equals to f of 1. So let us see for the value of the function when it is 1, when x is 1, f of 1 is 2. So let us first find out f of 1. So that is 2 already given. Now you need to find this. So limit x tends to 1, f of x is equals to, we have this function limit x tends to 1, x square minus 1 divided by x minus 1. So you can write limit x tends to 1, we can have x plus 1 into x minus 1, factorize it by x minus 1. So if you put 1 here and 1 here, then it becomes in the form of 0 by 0. That is called indeterminate form, that you have to remove that first. So we factorize the numerator, we get x plus 1 into x minus 1 by x minus 1, then we have a common factor both in the numerator and the denominator in the form of x minus 1. So we now just cancel these two. So we have finally limit x tends to 1, we have x plus 1. Now we put the value of x equals to 1, right? So we have 1 plus 1 and that is equals to 2. So what we find, that limit x tends to 1 fx whose value is 2 is also equal to f of 1 whose value is 2. So we can say that the function is continuous at x equals to 1. Okay. Now to continue, we move on to the next question number 5. Now to see the question number 5 is, a function f is defined as under fx is equals to x square minus x minus 6 divided by x square minus 2x minus 3 when x is not equals to 3, and it is 5 by 3 when x equals to 3. Now the question is, prove that fx is discontinuous at x equals to 3. So this is what you have to check. So now again, the function is, the value of the function at x equals to 3 is given to be 5 by 3. So if fx has to be continuous, for fx to be continuous, what is the condition? Limit x tends to 3, f of x equals to f of 3. So f of 3 is already known to us, that is given as 5 by 3. Now you need to find out limit x tends to 3 f of x. So limit x tends to 3 f of x is equals to limit x tends to 3 x square minus x minus 6 by x square minus 2x minus 3. Now if we put the value of x as 3, what will we get? It is 9 minus 3 6 minus 6 0, 9 minus 6 3 minus 3 0. Again this is coming in the indeterminate form, that is 0 by 0 form. So you have to get rid of this 0 by 0 form, and for that we need to factorize both the numerator and the denominator, and thereby we will cancel out the common factors from the numerator and the denominator, and whatever is left, there we will put the value of x as 3, and then we will check it with f of 3 whether it is coming to 5 by 3 or not. If it is coming to 5 by 3, the function is continuous. If the value is not 5 by 3, the function is discontinuous. Now since we have already been told that prove that the function is discontinuous at x equals to 3, that means when you solve this part, obviously you are not going to have this value 5 by 3. We will get some different value for this. So to proceed with this, let us first factorize the numerator and the denominator to get rid of this indeterminate form, that is 0 by 0 form. So we have limit x tends to 3. If you factorize this, this is x square minus 3x plus 2x minus 6. This is x square minus 3x plus x minus 3. So it will come to limit x tends to 3. If you take x common, this is x minus 3 plus 2 common, x minus 3. Here you take x common, then I have got x minus 3 plus 1 into x minus 3. So we have limit of x tends to 3. If you take x minus 3 common, we will left with x plus 2. In the denominator also we take x minus 3 common, we left with x plus 1. So you have the common factor x minus 3 cancel out, and now we put the value of x equals to 3. So in the numerator you have 3 plus 2 divided by 3 plus 1. So it is 5 by 4, and the value of the function at x equals to 3 is 5 by 3. Since at that left hand side is not is equals to the right hand side, hence it is proved that the function is discontinuous. So now to continue with, let us take another question. Question number 6. Find f of 0 if the function fx is equals to log of 1 plus x by sine inverse x by x not equals to 0 is continuous at x equals to 0. It is given that the function is continuous at x equals to 0. So now we write limit x tends to 0 f of x. It is given to be continuous, so f of 0 should be equals to limit x tends to 0 f of x. This is what you have to solve, and that will be the value of f of 0. This is equals to limit x tends to 0 log of 1 plus x by sine inverse x equals to limit x tends to 0 x by sine inverse x into log of 1 plus x by x. What we have done is this, we have multiplied in the numerator and the denominator both by x. So we have limit x tends to 0, we separate it, x by sine inverse x into limit x tends to 0 log of 1 plus x by x. So this is equals to 1 into 1, that is equals to 1. Limit x tends to 0, x by sine inverse x is 1, and limit x tends to 0 log of 1 plus x by x is also 1. So you get the value 1. Now we have to find f of 0 if the function this is continuous at x equals to 0. So if the function is continuous at x equals to 0, then if f is continuous at x equals to 0, then limit x then f of 0 is equals to limit of x tends to 0 f of x, and that is equals to 1. So the value of f of 0 is equals to 1. Okay. So now let us move to the next question. Now let us see to question number 7. A function f is defined as under fx is equals to sine inverse x by x plus e to the power x, and x not equals to 0, and it is 2 when x is equals to 0, so that fx is continuous at x equals to 0. So if fx has to be continuous at x equals to 0, then what is the criteria or what is the condition? The condition is limit x tends to 0, f of x should be equals to f of 0. So we already have f of 0 is equals to 2, right? So we have f of 0 equals to 2. Let us find limit x tends to 0, fx is equals to limit x tends to 0. See, x tends to 0 implies x tends to 0 implies x not equals to 0. It is approaching 0 but not 0. So x tends to 0 means x not equals to 0. So we use this function where it is x not equals to 0, right? So it is limit x tends to, you have to use this function sine inverse x by x plus e to the power x. So you can write separately sine inverse limit x tends to 0 sine inverse x by x plus limit x tends to 0 e to the power x, and limit of sine x tends to 0 sine inverse x by x equals to 1, plus if we put e to the x as 0, so e to the power 0 is also 1, so it is 2. So you see that we find that limit x tends to 0 f of x is equals to f of 0, and each is equals to the value 2. Hence the function fx is continuous at x equals to 0. Now I move on to question number 8. Examine the continuity at x equals to 1 of the function defined as fx is equals to 5x minus 4, x greater than 0, less than equals to 1, 4x square minus 3x, x greater than 1, less than 2. So here in this question we have to check for the continuity of this function at x equals to 1. Now you see, we have to check the continuity at x equals to 1. So we have two different functions on for values of x less than 1, less than or equal to 1, and another function for x greater than 1. So here we will be using left hand limit and right hand limit. Since we are having two different functions less than 1 and greater than 1, we have to use the left hand limit for this one and right hand limit for this one. And for that we have the condition. What is the condition? Left hand limit should be equals to right hand limit and should be equals to f of 1. This is the criteria. If the left hand limit is equals to right hand limit, then the limit exists. And then to check for the continuity, we have already done that the value of the function at the point of checking of continuity should also be the same. Now let us find the left hand limit first. Equals to limit x tends to 1 negative of fx equals to limit x tends to 1 negative. We have this function, so it is 5x minus 4. If you put x as 1, that is 5 minus 4, and that is equals to 1. Let us find the right hand limit. Right hand limit will be limit x tends to 1 positive of fx. So that is limit x tends to 1 positive, and the value is 4x square minus 3x. So you put x equals to 1, that is 4 minus 3, that is coming to 1. Now what is f of 1? So value of the function at x equals to 1, and x equals to 1 is here, the function is 5x minus 4. That is 5 into 1 minus 4, and that is 1. So what conclusion now can we draw from here? The conclusion is that left hand limit is 1, right hand limit is 1, f of 1 is 1. That means this function is continuous at x equals to 1, right? So one thing you must take into account is that the point at which the continuity is to be checked. If there are two different functions, one for the less than that value, one for more than that value, then we use left hand limit and right hand limit. Okay? And if not, if we have to given only one function and to check for the continuity at a particular point, then we will use limit x tends to f of x equals to f of a. Right? Now, please go through this and then we move on to question number 9. Here the question is, examine the continuity of continuity at x equals to 2. Of the function defined as fx equals to 2x minus 1 when x is less than 2, and it is 3x by 2 when x is greater than or equals to 2. So you have to check the continuity for this function at x equals to 2. Now since again we see that for the value of 2, for less than 2 and greater than 2, we have two different functions. So we will be using the left hand limit and right hand limit. So we have left hand limit equals to limit x tends to 2 negative of fx is equals to limit x tends to 2 negative less than 2, that is 2x minus 1, 2x minus 1. So we can write limit h tends to 0, 2 of 2 minus h minus 1, putting x equals to 2 minus h. So we have put h equals to 0, here the 4 minus 1, so this is equals to 3. If we put h equals to 0, so it becomes 2 into 2, 4 minus 1, that comes to 3. Now let us find the right hand limit. The right hand limit equals to limit x tends to 2 positive of fx equals to limit x tends to 2 positive greater than 2 more than 2, that is approaching from the right hand side, 3x by 2. So you can write limit h tends to 0, h tends to 0, 3 into 2 plus h by 2. So it is coming to 3. That is equals to 3. Now let us find f of 2. If f of 2 becomes equal to 3, because left hand limit 3, right hand limit is also 3, that means the limit exists. And then now if f2 also becomes 3, then this function is continuous at x equals to 2. So f of 2, this function, because x equals to 2, it is greater than equals to 2, you have to use this function. So it is 3 into 2 by 2, and that is equals to 3. So here we finally see that the left hand limit is equal to right hand limit is equal to the function at 2, value of the function at the point of continuity, that is equals to 3. Now what we did here is, we have written here in place of x, this particular step we have expressed this limit in terms of h and as well as the function in terms of h. Why? Because we have taken it as x equals to 2 minus h, and on the right hand limit you have taken x equals to 2 plus h. So as x approaches 2, h approaches 0. Similarly here, as x tends to 2, h tends to 0. So we have that left hand limit, right hand limit and f of 2 are all equal, hence this function is continuous at the point x equals to 2. Now we will take another question, that is question number 9. If fx equals to 1 when x is less than equals to 3, ax plus b, x greater than 3, less than 5 and is 7 when x is greater than equals to 5. Question is, determine the values of a and b so that fx is continuous. Now if you look at this function carefully, the domain of the function are all the real number values, right? So this function takes all the values which are real numbers. So that means this function is a continuous function. So in particular, if you have to see to the continuity, we will check the continuity at the breakpoints. What are those breakpoints? 3 is one of the breakpoints because the function changes, and 5 is the another breakpoint where function changes, right? So we don't need to check the continuity at each and every point of the function, but we will check the continuity at the breakpoints. Now since in the question it is already been given that fx is continuous, that we take that the function is continuous at the breakpoint 3 as well as at the breakpoint 5. So let us first see at x equals x is equals to 3. Obviously the left hand limit should be equals to the right hand limit should be equals to f of 3, and f of 3 is 1 given. So the left hand limit is limit x tends to 3 negative of fx, and that is 1, and right hand limit x tends to 3 positive f of x is equals to limit x tends to 3 positive ax plus b, so that is equals to 3x, that is equals to 3a plus b. Let us name it as equation number 1. We can do it in the same way, that is 3 plus x equals to 3 plus h, then h tends to 0, we'll finally get the same result. Now, so at one breakpoint, that is at x equals to 3, we got a relation, that is, sorry, not yet, this is not 1. Since left hand limit and right hand limit are same, so you can write, since left hand limit is equals to right hand limit is equals to f of 3, so you have 3a plus b equals to 1. This is number 1. Okay, this we give number 1. So we have an equation, linear equation in 2 variables. Now another, to find a and b we need another equation in 2 variables, and that will try to find out at the breakpoint, that is 5. Okay, so here only we do at x equals to 5, this will be 5. So left hand limit, that is x tends to 5 minus, means 5 negative. When it's 5 negative less than 5, we have this function x plus b. So we will write here limit x tends to 5 negative x plus b, so that will be 5a plus b. And when it is the right hand limit, that is 5 positive, and when it is 5 positive, it is value is already given, that is equals to 7. So this is equals to 7. So since, as we already know, this is a continuous function, and f of 5 is also 7, right? So we have 5a plus b is equals to f of 5, that is 7. So this is equation number 2. So these are the 2 equations we have got here, and after solving the 2 equations, simultaneous equations, we get the values of a and b. So let us now proceed to solve these 2 equations. So this is 5a plus b equals to 7, 3a plus b equals to 1. If we subtract these 2, so we'll change the sign here. So this 2 will be eliminated. We have got twice of a equals to 6. So a is 3. So from here we have 3a plus b equals to 1. So b is equals to 1 minus 3a, that is 1 minus 3 into 3. 1 minus 9, that equals to minus of 8. So we have a equals to 3 and b equals to minus 8. Let us check the answer here. A3 and b minus 8. So therefore we have finally a equals to 3 and b equals to minus 8. I hope you are getting all this, how to solve the problems based on continuity of a function, and this is the procedure that we will be following in solving each and every question. So in due course of time, when you keep on solving the problems, you will get more complicated problems, and then with more and more problem solving, you will be gaining in confidence, and then only we will be actually judging ourselves how much we have learned about this particular topic. So please look at this. Now let us proceed to question number 10. If the function f(x) is equals to 3ax plus b, where x is greater than 1, is 11 when x is equals to 1, and it is 5ax minus 2b for x less than 1, is continuous at x equals to 1. Find the values of a and b. So this is the question on the board. If the function f(x) 3ax plus b when x is greater than 1, is 11 when x is equals to 1, and 5ax minus 2b when x less than 1. So it is being asked in the question find the values of a and b given the condition. Given condition is that it is continuous at x equals to 1. So if the function is continuous, and since we have different functions for x less than 1, x greater than 1, so we have to use left hand limit and right hand limit. And since the function is continuous, we know that the left hand limit is equals to the right hand limit is equals to value of the function at the point x equals to 1. So let us write left hand limit for x less than 1. So what is the left hand limit? Will be this function will be using. So limit x tends to 1 negative f(x) is equals to limit x tends to 1 negative 5ax minus 2b, and that is equals to 5a minus 2b. Next, the right hand limit. So limit x tends to 1 positive of f(x) is equals to limit x tends to 1 positive greater than 1, that is 3ax plus b. So this comes to 3a plus b. So the left hand limit is 5a minus 2b, right hand limit is 3a plus b, and then value of the function at f of 1. F of 1 is given as 11. So we can write, I am rubbing the board here, no space to write. So we can have, we have the left hand limit is equals to the right hand limit is equals to f of 1. So you can write 5a minus 2b is equals to 3a plus b, and that is equals to 11. Okay, now we separately write the equations like this. So you can write 5a minus 2b is equals to 11 and 3a plus b is equals to 11. These are the two equations which you have to solve and get the values of a and b. So we can do is, if you multiply the second equation by 2, so we have 5a minus 2b equals to 11 and this will be 6a plus 2b equals to 22. Now we add the two equations. We have 11a is equals to 33. So you have a equals to 3. Now putting the value of a in either of these two, I am putting it here only. So it is 5 into a, that is 5 into a, that is 5 into 3. We write 5 into 3 minus 2b is equals to 11. So it is 2b equals to 15 minus 11. So 2b equals to 4 or b equals to 2. So therefore we have a equals to 3 and b equals to 2. Okay, so please have a look. Now we move on to question number 11. Find the value of k. Find the value of k for which the function f defined by fx equals to root over 1 plus kx minus root over 1 minus kx divided by x greater than equals to minus 1 less than 0 and 2x plus 1 by x minus 1 and x greater than equals to 0 less than 1 is continuous at x equals to 0. So now the question here is find the value of k for which the function f defined by fx equals to root over 1 plus kx minus root over 1 minus kx by x greater than equals to minus 1 less than 0 and it is 2x plus 1 by x minus 1 and x greater than equals to 0 and less than 1 and it is we have to find the value of k for which this function is continuous at x equals to 0. Now here also we see there are two functions for x less than 0 and x greater than 0, so again we will be using the left hand limit and the right hand limit. Now when we face this type of situations, so how to go ahead or proceed further in solving these type of situations? So what we do here is in class 9 I think or in the lower classes you have already studied about rationalizing. So this here, in order to solve this we have to rationalize both in the numerator and the denominator so that we can get our value, because if we put x as 0 here, this is root over 1, it is also root over 1, 1 minus 1 0 and this is also 0. So 0 by 0 indeterminate forms. In that case we have to get rid of this indeterminate form. So to solve this problem we have to rationalize. Okay, now I have to rub the board, no way out. since it is continuous, we have left hand limit equals to right hand limit equals to f of 0, value of the function at x equals to 0. So let us first find the f of 0. Now what is f0? f0 will be from x is 0 in this function, that is 2 into 0, that is 0 plus 1, 0 minus 1, so 1 by minus 1, that equals to minus 1. So f of 0 is minus 1. Now when it is left hand limit, and that is equals to limit x tends to 0 negative, less than 0. So we have to this function, we use this function. So this function is, I need to write it from the, so this is equals to limit x tends to 0 negative root over 1 plus kx minus root over 1 minus kx by x. So let us rationalize it in the numerator. What to do with, how to do rationalizing? So here this, we call this what we multiply with the conjugate. If it is minus, we multiply the same thing with plus in between. So it is root over 1 plus kx plus root over 1 minus kx. Again in the denominator the same thing, root over 1 plus kx plus root over 1 minus kx. So this becomes limit x tends to 0 negative a minus b into a plus b, that is a square minus b square. So we have 1 plus kx minus 1 minus kx by x into root over 1 plus kx plus root over 1 minus kx. So this is equals to limit 0 negative. If you open this bracket, 1 plus kx minus 1 plus kx, so 1 and minus 1 will be eliminated. So here kx plus kx is 2kx, and here it is x into root over 1 plus kx plus root over 1 minus kx. Now here x is eliminated. So if we now put x equals to 0, we get twice of k divided by, it is 1 plus 0 is 1, root over 1 is 1, plus 1 minus 0 is 1, root over 1 is 1, so 1 plus 1 is 2. So this is 2 and this is equals to k. So left hand limit is equals to k and the value of the function is equals to minus 1. So if we compare these two, because they are continuous, so we have left hand limit equals to the value of the function. So we can let us see. So from here we got the value actually k equals to minus 1, but we'll check with the right hand limit as well, and right hand limit value must be equal to minus 1, right? Let us check. We have already got the answer, that is minus 1 on the right hand limit. So it is limit x tends to 0 positive, that is 2x plus 1 by x minus 1. So let us put x equals to 0. We have it is 0 plus 1 and this is 0 minus 1, so you have got minus 1. So obviously right hand limit, as we have already has told you, that it has to be minus 1, because in order to that the function is already being given, this is continuous, so you have f0 equals to minus 1, and left hand limit you have got, that is equals to k, and right hand limit is equals to minus 1. So obviously we have k is equals to minus 1. Okay, so now that we have solved a few questions on this topic, continuity of a function, hopefully you have understood it. Now keep practicing as many problems you can, and that will give you the confidence, the boost to solve many problems. And in case of any doubts, also you can consult your mentor, immediate mentor, who can help you. So have a nice journey.